particularly we will take a look at some specific type of salt, like the sodium chloride, which is the table salt or the common salt that we consume in our food. Then we'll be having the topic acid base and indicator. Okay, acid base and indicator. So let us start the chapter. See, in our day-to-day life, there are different type of substances, different type of food that we consume. Some of the food that we consume have got a sour taste. Some of the food that we consume have got a bitter taste. Right now, it has got a bitter taste. So generally, the food that has got a sour taste, right, that has got a sour taste, are called as acidic food. Are said to have said to contain acids in them. And then generally, the food items or the substances that have a bitter taste, that is said to have a basic nature, that is said to have that is said to contain base in it. Getting it? So talking about the acids, acids are basically the substances that gives you a sour taste. Okay, now plus they are corrosive in nature. Like when they are dropped on metals, so they can eat the surface of the metal, or when they are dropped on any surface, if they're strong enough, they can make it rough, they can eat the surface of the given object. So they are said to be corrosive in nature also. Like we can observe this thing, like suppose if the acid like hydrochloric acid is taken, and if it is a strong hydrochloric acid, and if it were to be dropped on marble, so you will see that it will eat the surface of the marble. It will basically damage the surface of the marble. Getting it? Or by accident, suppose in the lab, if someone is uh, basically doing some experiment with acids, and if some drop of acids were to fall there or fall on their skin, now it will burn their skin. Getting it?
Sir,
Yeah.
sir, can you explain what is hydrochloric acid?
Hydrochloric acid is a strong acid. Okay, no, it's a mineral acid that is prepared in the laboratory and can be found in natural substances also, like our human body, particularly our the inner lining of the stomach also produces hydrochloric acid. There are different type of acids, like some of them are weak, some of them are strong, some of them are found in nature, some of them has been made in laboratories. Getting it? So hydrochloric acid is considered as a strong acid. Getting it?
Okay,
Then you
sir.
have got some type of acids that we'll be learning about the types of acids. We have a separate section for that. Okay, now. So acid, bases, and the salt. The chapter name is acid, bases, and salts. So these are the three important groups of the chemical substances which are useful to us in many ways. Just before this, we have learned the chapter nutrition and animals, now where we learned that our stomach makes an acid called as hydrochloric acid, which is necessary for the digestion of the food, right? Then in the kitchen, like baking soda is used now. It is used, it is added in some food items. It is used in baking the bread now. Baking soda, you know about that, Salman? Baking soda.
Yes, sir.
Huh? So what is that substance? It contains base in it. Okay, na? It contains a base in it.
Yes.
Whereas common salt, like sodium chloride, it is used in cooking food now. So that is basically salt. While some of the acids, bases, and salt they occur in nature, whereas many acids and bases and salt they are made artificially in the factories. We made them in the laboratories, particularly. Okay. However, many of the chemical substances now, like water, like glucose, like urea, uh, they are neither acids nor bases nor salt. Does water have got any taste?
No, sir.
Obviously, no. So we can neither call water as acid, neither a base, neither nor a salt. So there are some substances which cannot be categorized in either of these categories, which cannot be a base, not an acid, and not even a salt. So that is the
So,
thing.
like, is acidic as acid,
Repeat again.
like Pepsi liquid,
That is
Sprite.
acidic. Yeah, that is acidic. It contains carbonic acid in it. Carbonic acid is found, and it is very bad for the health. Usually people would be consuming it. It is, in the long run, it is going to be very deadly for our health, so one should stop consuming these. Okay, now further, we cannot go on to taste every substance to know whether it is acidic or basic in nature. Generally, acids are substances that have a sour taste, or bases are the substances that have a bitter taste. While taking a bath, sometimes what happens, the soap particles or the shampoo might enter into our mouth. Sometimes it happens, let's say, accidentally. So it gives a very bitter taste, right? Now, gives a bitter
Yes.
taste. So that is having a base in it. Those are basic substances. So, in order to say whether a given substance is acidic or basic in nature, suppose if I were to be provided with a liquid and I need to know whether it is acidic or basic in nature, so I cannot go on to taste it. Why? Because suppose if it is a very strong acid or if it's a very strong base, so it can harm me, it can cause harm to me. So that's why we use special substances called as acid base indicators. There is special type of chemical substances that are used to test whether a given substance is an acid or a base, just like you have got a litmus paper that you will be dipping in the solution. When its color will change, it will tell you whether that substance is acid or whether it is base in nature. Okay, no? So litmus paper is there. Other than that, there are many other substances also. Many times, suppose we are eating some food and that food item particularly contains turmeric powder. Turmeric, you understand, a haldi basically.
Yes,
Okay,
sir.
and when that cloth will be washed, there's a stain on the cloth of that food particle, and that food particle had haldi in it, had turmeric powder. So when the detergent powder is added into it, you might have noticed how the color turns reddish. Have you noted it?
Yes.
Huh?
Yes.
So those things we are going to learn why it has happened, and also with the example of that we can understand, like, turmeric is yellowish in color. Now when it comes in contact with the basic substance, it turns red in color. So suppose if this is an unknown liquid and I add few amount of turmeric powder in it, turmeric is usually yellowish in color. After addition of it, the color, let's say, not changes red in color. So this means that the given substance was basic in nature. Getting it? No? So we'll be learning about all those things. As of now, let's learn about the acids. So acids are substances that taste sour and are corrosive in nature, mean that they'll be eating the surfaces of objects. They can even burn our skin. Then they will turn the blue litmus paper to red. We'll be learning later on about the litmus paper in detail, but in wherever we have to define acids, we must write down this point that they turn blue litmus paper into red. We must write down this thing whenever we have to define about acids. Litmus paper, it's basically a type of paper, it's type of indicator. If you have taken a blue litmus paper and if it is dipped into the acidic solution, it turns into red color. Thereby, it shows that the given solution is an acid. Okay. Various examples of acids are like orange juice contains citric acid, curd, vinegar, hydrochloric acid are some of the examples. Now, acids can be categorized in two different types, in two categories. There are two different types of acids. Okay, na? So one is the strong acid, another is the weak acid. Strong acid, also we call that as mineral acids. On the other hand, we have got weak acids. Okay, weak acids. Strong acids, like some of the examples of the strong acids are like hydrochloric acid, hydrochloric acid. Then you have got like sulfuric acid is there, or let's say you have got nitric acid. So strong acids are highly corrosive in nature. They're highly corrosive in nature. Like if they were to drop on some substances, they can cause so much of damage to it. Getting it? They can eat the surface of the metal. They can burn the skin. So those are the strong acids. Okay. On the other hand, we have got the weak acids. like they are found in natural substances. They are edible in nature. Okay, now so weak acids are, for example, in the
Acetic acid.
acid, exactly. Vinegar
Lit-
contains acetic acid. No,
Litric.
repeat again.
Litric acid.
Litric acid or citric acid? You are trying to say
Yes, sir. Citric.
citric acid. No, so we have got acetic acid, and it is found in the vinegar. Vinegar, you understand? No, also called as sirka, right?
I was telling that lactic acid.
Oh, lactic acid, you are trying to say. Very good. Citric acid, it is found in the citrus fruits. Okay. Then we have got the lactic acid. Where is it found? In the curd, particularly. In curd, it is found. So these are some of the examples of weak acids. So the major difference between a strong and the weak acid is that the strong acids are highly corrosive in nature. Highly corrosive in nature. Okay, na? Plus, like they would be giving a very strong smell. If you try to inhale the smell coming out of it, it can cause some irritation in the nasal passage. But the weak acids, they will not be causing harm to us right now. Although if we consume that in excessive amount, it can lead to some problem, but they are not going to cause so much of harm. Further, strong acids are better conductors of electricity. You know that acids help in conduction of electricity. Okay, now so they are better conductors of acids, meaning that they will let the electric current pass through it. Okay, and as for the weak acids, in comparison to that, they are poorer conductor of electricity. Hope that much is clear to you. Okay,
Yes, sir.
then there are different sources of acids. Like based on the source, we have got natural source, and then we have got artificial source. So natural sources are basically the like they would be coming from the different type of food items. So like we have got acetic acid, formic acid, citric acid, lactic acid is there, tartaric acid is there, ascorbic acid, oxalic acid. Hmm?
Sir,
Uh-huh.
formic acid is weak or strong?
Formic acid.
Yes.
Formic acid will be considering this as slightly strong, not that strong, but slightly strong. Okay, na? Because when we are bitten by an ant, no, the sting of the ant contains formic acid. The ant would be pushing its sting into our skin, and the ant would be releasing the formic acid. So it gives you a sharp pain, right? No? So it is quite strong, but will not be considered as a very strong acid. Okay. So formic acid, grapes contain tartaric acid. Apples also contain acid. That's why it has a sour taste. Milk contains lactic acid. Lemon contains citric acid. Other than milk, curd also contains lactic acid, and tomato contains oxalic acid. Okay, now tomato contains oxalic acid. So that is the thing. Do we have tamarind over here? So tamarind also contains an acid. So tamarind contains tartaric acid in it. Okay, Salman, it contains tartaric acid in it. Even this oxalic acid is also found in spinach also. If you have eaten, you would know that spinach also has got a slightly sour taste. Okay, now then there is one more type of acid called as ascorbic acid. Ascorbic acid, and this is found particularly uh, it is found particularly in citrus fruits like amla. You know about amla? Have you heard of amla? Right?
No,
So
sir.
there it is found. You haven't heard about it. It's okay. It is found there. Okay, now this ascorbic acid, we commonly call this as vitamin C. So ascorbic acid is
Sir,
commonly
amla?
here.
What is amla?
Amla, okay, I will show one image of it. Ascorbic acid is commonly called as vitamin C. Okay, now that is an important point to note down here. So we learned about tamarind that contains tartaric acid. Amla contains ascorbic acid. So all these different types of acids that you're seeing here, we are calling them as organic acids. What are they?
Organic acid.
Organic acids. In other words, they are natural acids. Okay, now do we have to prepare them in the lab? Obviously, no. They are simply occurring in the nature now. That
Sir,
is the thing.
sir, lemon is a strong acid.
Lemon, it's a weak acid. It is contained. It is considered a weak acid. Okay, now.
All
So
these are a normal acid.
all these are weak acids. Okay, now all the naturally occurring acids are considered as weak acids. It is not harmful to eat or drink those substances that contain naturally occurring acids in them. Like we can eat oranges or drink oranges juice now, although
Yes,
they
sir.
contain natural acids. So similarly, we can consume lemon juice also because it contains organic acid and it does not harm us. On the other hand, we had some examples of the strong or the mineral acids also, no, where we learned that they are prepared from the chemical substances, right? Now they are prepared from the minerals uh, of the earth, right? So some examples were hydrochloric acid, sulfuric acid, and nitric acid. Okay. Also, mineral acids have got use in daily life. Like for example, hydrochloric acid is used in cleaning the kitchen sinks now and bathroom sanitary ware, like the wash
Yes, sir.
basins or the toilet seats that can be cleaned with the help of this hydrochloric acid. Okay. Then, if you have got highly strong acids, right now, so they can be very, very dangerous. These
Sir,
acids can burn our hand and clothes. Yeah.
sir, hydrochloric chloric acid can kill germs.
Yeah, it will kill most of the germs, right? But it needs to be strong hydrochloric acid. Okay, no? Like
Okay.
even if it is a strong acid, no, by the addition of water, it can turn into weak acid. Later on, I will tell you how, if we were to be provided with a strong acid, how we can make it weak. Okay. So if it is weak, it is not going to kill, but if it is a strong, it is going to kill. Okay, no? So that is the thing. Let me tell you one more thing about this. Hold on. See.
Sir, you told you will show amla.
Yeah, I told you. I told you. Let me show image of that. I forgot like what do we call that in English? Yeah, this is the one I was talking about. See, so this contains ascorbic acid. Getting it?
Okay, sir.
Have you seen this or have you eaten this?
I did not see and I did not eat also.
Oh, okay. See, further I was telling you about the concentrated and dilute acids. Okay, now concentrated acids, and then we have got dilute acids. So concentrated acids are basically, they are very, very dangerous. Like they can burn our hand and clothes, and they should be handled with great amount of care. Okay, so they are highly dangerous. They contain less water in them. While while these acids are so much dangerous now, like they can cause so much of damage. So generally, the concentrated acids are mixed with water to dilute them. So such acids in which water has been added, they are called as dilute acids. Okay, now so water is added to the concentrated acids, and such acid is called as dilute acids. they are less harmful to us. That does not mean we can pour it over hand or we can pour it on the clothes, but it is still harmful but less harmful. So that was the thing. Okay. Further, you can see how we can dilute an acid. How we can dilute an acid. So suppose if someone has taken acid in a glass beaker, and if they were to directly pour the acid over it, so it will lead in a explosion. It will lead to explosion. There will be a small amount of explosion. So the right manner of diluting an acid is that what you can do, we can take a beaker, fill it with some amount of water as per the requirement, and then drop by drop keep adding acid in it. And via a stirrer, like via glass rod, keep stirring it, keep mixing it. So that is the correct method, that we should always add acid to water and not water to acid. Got it now? Other than this thing, we need to wear the safety gloves also, safety spectacles and gloves. We need to wear the safety gear also. That is one thing. Okay. Then there are different uses of acids in our daily life. For example, sulfuric acid, uh, it is used in the batteries. It is used in manufacturing of the paint as well. Then
Yes,
carbonic
sir.
acid, it is used in the aerated drinks. Getting it? Nitric acid, it is used in the manufacturing of fertilizers. Hydrochloric acid, it is helpful in digestion. Sulfuric acid, it is used to make aspirin, a medicine. Acetic acid, it's a edible acid found in the vinegar. Getting it now? Then, by the help
Sir,
of the hydrochloric acids, sinks and sanitary ware are also cleaned with the help of the hydrochloric acid now. So they are used in day-to-day life activities. Okay, now that is one thing. Further, there's one more topic about the acid rain. That is acid rain. You must have heard about acid rain, right? Okay. So the rain which contains a higher level of acid than normal is called as acid rain. And acid rain is caused due to the release of acidic gases like sulfur dioxide, nitrogen dioxide, and carbon dioxide, which are being released into the air when we are burning different
and
type of fuels. Yeah.
the rain mixes with them
Repeat
when
again.
it comes. That acids are in air, right? Mixes with air, right? Then when the rain will come. That acid will mix with the rain and fall down.
Exactly. So what is basically happening now? See that these are the clouds and precipitation is happening here. Like these are the precipitation, raindrops falling from the cloud. And at the same time, there are gases like carbon dioxide gas, uh, sulfur dioxide gases, sulfur dioxide gases, okay, nitrogen dioxide gases, nitrogen dioxide. These gases are being released from the chimneys, from the vehicles, okay, na? Due to the burning of fossil fuel,
Yes, sir.
burning of fossil fuel, these gases are being released into the air. So they are rising up. Okay. And as they will be rising up, so they will mix with the raindrops. They mixes with the raindrops. Before this, the rainwater was good. It was clean. But what has happened? These pollutants, namely sulfur dioxide, carbon dioxide, and nitrogen dioxide, all of these are different type of gases. Okay, now all of these are different type of gases, and they are getting mixed with the raindrops, and then they form acids. So they will be forming acids. So now the raindrops that are falling after being mixed with it, so they have converted into acids like sulfuric acid, okay, like nitric acid.
Sir, when water fall down, it will very pure water, very clean water.
Hmm,
But when the gases mixes with the water, when it fall down with gases, it will not like
hmm,
very clean.
exactly, right. because now that rainwater is containing these acids, namely carbonic acid, sulfuric acid, and nitric acid. What
Yes, sir.
happens when carbon dioxide mixes with water? Carbonic acid is formed. When sulfur dioxide is SO2 over here. Okay, now I'm writing it in short. Sulfur dioxide mixes with water, sulfuric acid is formed. When nitrogen dioxide, NO2 is for nitrogen dioxide. Okay, now when this mixes with water, nitric acid is formed. So the presence of the sulfuric acid, nitric acid, and the carbonic acid in the rainwater makes the rainwater acidic. And when this acidic rainwater falls on the earth, we call this as acid rain simply. It will cause damage to the aquatic animals like the fishes. It will cause damage to the trees, to the crops, to the metal structures, particularly to the stone buildings and the monuments. Even if we were to stand in such a rain, our skin will also be damaged. Okay, now? So it
Yes,
has
sir.
many harms. It will make the water of the lakes, ponds, and rivers too much acidic. If it becomes highly acidic, so thereby the fishes and other aquatic animals may get killed now. It will eat up the leaves of the trees now. So by losing the leaves, the tree will die. Okay. It will damage the surface of buildings and monuments that will be made up of stones, particularly. So hope that much is clear to you about acid. Okay.
Yes, yes.
Okay, give me a minute. Now, suppose if you take some baking soda, you go to kitchen and let's say you take some baking soda and you taste it. It appears to have a bitter taste, right?
Yes, sir. Sir,
And if you uh
uh, in tea, which acid is present? Tea.
in which in tea,
Yes,
the tea that we consume,
yes,
you're saying in tea which acid is found?
yes, sir.
I don't think it has any acid in it. Tea particularly, you're saying. Hold on, like
Yes, sir.
if you're only pure tea, like nothing is added in it, no? Okay. Then in that case, tannic acid is found in it. Let me write it somewhere. Tea would be containing tannic acid. I thought like you're saying like when we add some other things in it, like sugar or milk or some other things. In that sense, I thought you're asking. So tannic acid is usually found in the tea. It's clear to you?
Yes, sir.
Okay. Now getting back to the next topic, that is about the bases. So I was telling you that suppose if you take some baking soda and you taste it, so it appears to have a bitter taste. Also, if you were to rub a solution of baking soda between your fingers, now it will give a soapy touch, which is like it is slippery to touch. Okay, now. So the substances like baking soda, which are bitter in taste and gives a soapy feel to touch, they are known as bases. They are basically in chemically they are basically opposite of acids. Okay, now they are basically opposites of acids. Bases are substances that in their aqueous solution. What does aqueous solution mean? That when it means that water should be present in it. It should be in the liquid form. It should not be in the dry solid form. So when they are in their liquid state, they are slippery to touch and they give a bitter taste. So that is the thing. Further, they are just opposite of the acids. Okay.
Yes, sir.
Further, what will happen when bases are added with the acids? When they are added with the acids now, so they cancel the effect of each other. They neutralize the effect of acids. When bases are added with the acids, they neutralize the effect of acid. So, a substance, we can also say that a substance which can neutralize an acid, which can neutralize an acid to form a salt and water is called as base. We can give one another definition of base also now. First, we say that a substance in the liquid solution that is slippery to touch and bitter in taste is called as bases. Also, a substance which can neutralize the acids to give salt and water is called a base. Further, the bases would be turning red litmus paper to blue. If suppose you have taken a basic solution and you have in this you have dipped a red colored litmus paper. After dipping the red colored litmus paper in it, if the color changes to blue, thereby it indicates that the nature of the given solution is basic in nature. Got it?
Yes, sir.
So thereby it has converted into blue color, and this was the red litmus paper which we had. Okay. Some of the examples are like soap. Soap contains base in it now, ammonium hydroxide, calcium hydroxide, etc. Let me write down some of the examples. Some examples are as follows. Like you have got sodium hydroxide. Sodium hydroxide is an example. Ammonium hydroxide is an example. Then calcium hydroxide. Calcium hydroxide. Further, you have got magnesium hydroxide also. Magnesium hydroxide. Okay, let me write one more example. So you can take sodium hydrogen carbonate. Sodium hydrogen carbonate. And the last one which I have written, it's basically the chemical name of baking soda. Baking soda is the household common name which we use, but its chemical name is sodium hydrogen carbonate. So these are some of the things. One more important thing is that a base which gets dissolved in water, we call it as alkali. Okay, now bases are called alkaline also because some of them are soluble in water, whilst many of them will not get dissolved into water. But the one that gets dissolved into water, we are calling them as alkaline. Hope that much is clear to you.
Yes, sir.
Okay. Then, just like acids, bases can also be strong and weak now, right? So they can also be strong and weak. So some of the strong bases are as follows. Like, for example, sodium hydroxide. Sodium hydroxide is a strong base. Potassium hydroxide, that is also a strong base. Potassium hydroxide. Of a weak base, you can take the examples like you have got calcium hydroxide or like magnesium hydroxide. Right, magnesium.
So like potassium hydroxide.
Potassium hydroxide is the example of a strong base actually. I have
Yes,
written it this side. Then you can have sodium carbonate. Okay, now sodium
sir.
carbonate. Uh-huh.
Sir. Ammonium hydroxide.
Very good. Ammonium hydroxide also. Okay, we have many more like sodium hydrogen carbonate, that baking soda. Huh. Sodium hydrogen. Let me write this over here. Hydrogen carbonate. So these are the strong and the weak bases. Okay, now. So sodium hydroxide and the potassium hydroxide, they are strong bases. Sodium hydroxide, it is commonly called as caustic soda. It's a common name called as caustic soda. Okay, now. Just like sodium hydrogen carbonate is called as baking soda, similar to this, it has also a common name. Okay.
Yes,
And
sir.
the word caustic here, let us understand what does it mean. So let me write it over here. See, caustic. The word caustic means something that is corrosive in nature or burning. It means corrosive or burning, right? So sodium hydroxide is very dangerous. Like it is very strong, so it must be handled very carefully. Okay, now like if it were to be kept in our hand, kept on our skin, it can burn our skin. sodium hydroxide and also potassium hydroxide, it can burn our skin. So they are that much strong. They must be handled carefully. On the other hand, calcium hydroxide, ammonium hydroxide, sodium carbonate, etc., they are weak bases, but the solutions are unsafe to drink. Although they are weak, but it's not like we can add them into water and we can drink them. In the case of acids, weak acids are safe. Okay, no? Particularly the organic acids are safe. Organic acids
So,
are safe.
like bases are just like liquid, and there are hydroxide.
Liquid meaning that I'm saying that bases we cannot drink the solution of the bases, even if
Yes,
it is
but
weak. Mhm.
I'm telling that calcium hydroxide is just liquid, right?
Yeah, yeah, it comes in the liquid form also. Yeah, ammonium hydroxide, sodium carbonate, everything is available in the liquid state also. Okay, no. Also, an important thing to note down is now whether it is acid or whether it is an acid or whether it is a base. In order to check if it is acidic or basic, it must be in the liquid state. You cannot check it if it is in the dry or solid form. Okay, Salman, it must have some amount of water in it. It must be in liquid state. Okay, that is one thing. Also, you know that in the previous class, like in the previous chapter, we have learned about the tooth decay. Now we know that some of this sugary food eaten by us is converted into acid by the bacteria present in our mouth now, and
So,
that causes tooth decay, right? So the toothpaste which we use for brushing and cleaning our teeth, should it be acidic or should it be basic?
so acidic.
Toothpaste should be acidic. No,
No,
it is basic in nature actually, because the bacteria in our mouth are producing the acid. The food that we are eating, the bacteria would be consuming it to produce acid, particularly when we eat too much of sugary substance. So more bacteria are produced. They'll be converting more amount of producing more amount of acids in our mouth. So in order to neutralize the acid in our mouth, we must consume the toothpaste and consume, I mean to say, basically brush our teeth with the toothpaste, and toothpaste is basic in nature. So it neutralizes the effect of acid in our mouth, and hence it will be preventing the tooth decay. Got it or not?
yes,
So
sir.
thereby we have got different uses of bases. In the manufacturing of soap, sodium hydroxide is used. For manufacturing of detergent, sodium carbonate is used. In the labs, also different type of bases are used. In the manufacturing of cement, calcium hydroxide is the base that is used. In toothpaste, sodium fluoride is used. In fertilizers, ammonia is used. So these are some of the different uses of the bases which we have. Got it? Particularly in the window cleaners, ammonium hydroxide is used. Ammonium hydroxide is used in the window cleaners. Okay, now in the window cleaners. So that is the thing. Other than these, there are some special type of bases which we are going to discuss about. Okay, but following are some other uses also. See, about the soap, toothpaste, we have learned even in the manufacturing of paper and rayon. Rayon is a type of cloth. There also bases are used. Base like sodium hydrogen bicarbonate, hydrogen carbonate, or basically baking soda is used in the baking industry now, right? Then some of the bases are used to make detergents also. Getting it now? So there are different uses of bases. Particularly, if you were to talk about bases like this one, like calcium hydroxide. So to obtain calcium hydroxide, we are going to learn like where do we obtain it from, this calcium hydroxide. Okay, now this is the calcium hydroxide, and it is a weak base, right? We learned about this. It's a weak base now. So let us understand like how do we obtain it. So first of all, limestone, it's a type of rock and it is made up of calcium carbonate. Okay. And further, from calcium carbonate, we obtain quicklime. I'm saying that it's the limestone, and from limestone, we obtain quicklime, that is CaO. Where do we obtain it? Where do we obtain quicklime? Where do we obtain it from? From the limestone. Now let us understand what will happen when we mix water to the limestone, to this quicklime. Basically, what we are trying to discuss here, how we can prepare the calcium hydroxide. And where do we use it? We are going to learn about it. It's calcium hydroxide. In the rural household, you might have seen that still they would be painting their house with traditional methods. They do not, they won't be using the uh, chemical paints, but rather would be using traditional methods. So take a look at this video over here. See, the video starts from here. This guy has taken some quick lime in the bowl here. Turn your camera on, Salman. This guy has taken some quick lime in the bowl and he has poured some water over it. The moment he poured some water, you will see that it will be giving so much of bubbles and like so much of heat is being released here. You can even hear a little bit of explosion here. You see those vapors coming out of it actually because of so much of heat. Some of the some of it is getting converted into vapors also. Now you will hear the like there will be a bit of explosion. Getting it. So what has happened here?
Sir, it is not hot water.
Hmm? After addition of water, what happened? There was an explosive reaction. Getting it? So quick lime is basically these stones that you have seen in this. These stones that were added in the ball, no, in the yellow ball, that is basically called as quick lime. Okay, or basically calcium oxide or quick lime.
Sir,
Yes.
is this hot water?
Like we can take hot water, but in the given experiment, it's normal water, neither cold, neither hot, lukewarm water. Okay, but if you were to add hot water, no, it's going to be a highly explosive, right? Like the reaction would be more vigorous. It would be more violent reaction. Okay, now. So then, after addition of water to the calcium oxide, we get calcium hydroxide, and calcium hydroxide can be used to paint the houses also. Basically, it is used for its use is in whitewashing. You know, walls are whitewashed. No, whitewashing of the wall is done. Getting it? So there it can be used. So these were some of the uses of it. Now let's do some questions and then we'll be moving to the next topic. From the acid, from the topic acid, let's do these questions. Answer these questions.
Sir, for the first one, it is acetic.
Hmm.
Sir, for the second question, formic acid.
Very good. Also, you know what is the cure when we get bitten by an ant? So what can be done to get cure, get relief from the pain? What we can do, we can take some baking powder and rub it over the area where we have been bitten. Okay, Salman? Because the baking soda contains a base, and we know base is a substance that neutralizes the effect of acid. So we will no longer feel the pain when we rub baking soda over it. Answer this question. Which base is found in the window cleaners?
Sir, lactic.
Lactic, it's not even in the option. Which base is found in the window cleaner?
Ammonia.
Lactic acid is no, that is not even found there. It's not even in the option.
Sir, ammonium hydroxide.
Exactly. It's the ammonium hydroxide which is basically used in the window cleaners. Okay. So here we have learned about the acids and the base. To sum it up, we have learned that acids are basically substances that have a sour taste, right? Bases have a bitter taste. Acids are not soapy to touch, while bases give a feel soapy to touch. Acids turn blue litmus to red, while bases turn red litmus to blue. Okay. Now we will learn about neutral substance, but first we're going to learn about the neutralization reaction. So what happens when an acid would be reacting with the base? They would be canceling out each other's effect. They would be neutralizing each other. Suppose an acid by the name of hydrochloric acid here. This hydrochloric acid has reacted with sodium hydroxide, which is a base. This is sodium hydroxide. So when these two would be reacting, then water along with the salt is released. This is basically water. So acid plus base gives us water. Along with water, a neutral substance called as salt is formed. Neutral substances called as salt and water is formed. Water is also neutral, right? So these are the substances that are formed in this. So whenever an acid and a base react with each other to give salt and water, right? So then such a reaction is known as a neutralization reaction. And in this reaction, the acidic and basic nature of basic nature is lost, like they are kind of destroyed. Okay, now. And this reaction between hydrochloric acid and sodium hydroxide is the classic example of the neutralization reaction. Hope you have understood it this much.
Yes, sir.
Good. There are different applications of neutralization in our day-to-day life. There are various um, instances where we can see neutralization happening in daily life. Like when people suffer from indigestion, there will be like acidity. When there is excessive amount of hydrochloric acid produced inside the mouth, inside the stomach. So it leads to acidity now, gives a burning sensation, right? So in order to neutralize the effect of the excessive acid produced in the stomach, people would be taking in this milk of magnesia, which is nothing but basically a liquid solution of magnesium hydroxide. And what is magnesium hydroxide? It is an acid or base. It's a base now,
Yes.
right? So when the person would be taking in this magnesium oxide, so what will happen? As soon as either we take it in the form of tablets or either we take it in the form of solution, it will react with the acid, neutralize it, and then we get the relief. We get relief from the problem. Before, what has happened? There is excessive release of acids, and those acids can go back, like it can go into the food pipe also, and hence sometimes gives a burning sensation is the chest also. So we will get relief from it once we take antacids. So magnesium hydroxide is basically an example of a antacid. Okay, now antacids basically like these are kind of medicines that gives us relief from acidity. Then further example of neutralization reaction is the effect of ant dusting, which is caused by formic acid. So there again, when we are rubbing the moist baking soda over it, so there's going to be reaction between the acid and base now. So that is also neutralization reaction. That is one thing. Further, to ensure that the plant grows properly, we need to first of all check its pH level. pH level basically helps us to understand the nature of the soil, whether it is acidic, basic, or neutral, whether it is highly acidic or less acidic, highly basic or less basic in nature. So there's a range from 0 to 14.
Sir,
Okay.
how found?
How do we?
Found?
What do we like? In what sense you're asking?
Sir, how do we found?
I don't. I'm not getting your question. Like, how do we found like what?
Sir,
Whether it
how?
is one, two, three, or four,
In the,
like that you're saying.
yes, sir.
Okay.
How do?
Basically, we will take the pH paper. Okay, and we will take the sample. Okay, and we will basically put the pH paper into the solution of the sample. Like we can take some water, add some soil in it. A solution is now ready. We will drop the pH paper in it. If let's say the color changes to green like this, so the pH level is 6 or 7. If the color of the pH paper turns or red in color or orange, it means it is highly acidic in nature. If it turns purple or blue, it means it is basic in nature. So in this manner, we can find out whether it is acidic, basic, or neutral. So the ideal pH level, which is good for the plant's growth, it is 7. The ideal pH level is 7. If it is more than 7, it is not good. If it is less than 7, it is not good. So suppose if the pH level of the soil right now, let us suppose if it is 14. So it means that the soil is highly basic in nature now. Soil is highly basic in nature. So if it is highly basic in nature, we need to add acidic substances to it. Getting it? So if the soil is acidic in nature, so thereby we will add manures to it. When we add manures you understand? Basically, these are organic fertilizers prepared from the decaying remains of the plant waste, animal waste, cow dungs, etc. When they will be decomposing, so manure is formed. So when this is added into the soil,
Sir,
okay, sorry, I told it is highly basic in nature. Yeah, tell me.
sir, what is cow dung?
Cow dung. Cow dung is basically like the excretory material released by the cows now. The excretory product of the cow is basically cow dung. Cowdung. Cow dung. It's the excretory product kind of released by the cows. So when we add manures to the basic soil, so those manures will be releasing acid. They releases acids, and then what happens? The acids react with the bases, and thereby now the soil turns the pH level turns back to neutral. Why so? Because the addition of the manures have released acids, and those acids reacted with the base to neutralize the soil. So hence a neutralization reaction has happened here. Okay, now hope you're getting it. Okay.
Yes, sir.
Further, many times when factory waste are being released into the water bodies, generally they are acidic in nature. So they must be treated with chemical substances. They must be first of all neutralized before discharging into the water bodies. So those were some